Okay, guys, so at this point, we've done a lot of exponents, and we're pretty familiar that exponents represent really, really big numbers. For example, if I have a base of 7 and I take this to the 6th power, I know this is something big. 7 times itself 6 times, it's always surprisingly big. Holy smokes, that's a huge number. That's 11. No, it's 117,649. Holy smokes. Sometimes I even don't believe myself, and I just do 7 times 7 times 7 times 7 times 7 times 7 again. And it's the same thing. It's huge, okay? Now, it turns out that if you have a negative exponent, for example, 7 to the negative 6, this represents a teeny, 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 tiny number. Positive exponent, really, really, really big number. Negative exponent, really, really, really teeny, tiny number. And it turns out, are these numbers even related? Yes, they absolutely are. So this right here is the same thing as 1 over 7 to the 6th power. Yeah, really, really tiny number. This is a really big number, but the fraction is really, 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 really small. In fact, this is the same thing as 1 over 117,649. 117,600. I can't even say it. It's really, really, really small. And you know what? Sometimes it helps to know what that is as a decimal. So let's actually figure that out. What is 1 over 117,649? Approximately 0.00. How many zeros is that? 1, 2, 3, 4, 5 zeros. 85. So, yeah, ridiculously small. Yeah, and just for kicks, let's let's put that negative exponent in my calculator. So let's actually do that. 7 to the negative 6. Let's see what we got here. 7 to the negative 6. And there it is. So the same thing, proof. Yeah, and so to sum this up, the rule of negative exponents, guys, is all you have to do is, here's another example. All you have to do is write it as a fraction, 1 over 10 to the positive. So rewrite it as a fraction and change the exponent from negative to positive. That's your rule of negative exponents, guys. Thanks for playing.